Harriet is comparing the costs of calling cards. To use card A, the cost is $1 to connect and then $4 a minute. To use card B, it costs 65 cents to connect and then 6 cents per minute. For what number of minutes does it cost the same amount to use each card for a single call? Okay, so this is a practical question because this is something that may come up for you. Perhaps calling cards aren't as prevalent as they used to be, but other services use similar pay schemes. So again, there's an initial cost just to make the phone call, kind of like a taxi ride. Just to even step in the door and take a seat in the taxi, there's an initial cost, and then for every mile you travel, there's an additional. Same thing with calling cards. $1 to connect, 4 cents per minute after for one card, and another card, 65 cents to connect, and then 6 cents per minute you use the phone after. So we need to write equations to represent each one of these calling cards. Now, notice that there are two variables at play. One is just the total cost of a phone call, and the other is the number of minutes. We're going to let x equal the number of minutes. X is our independent variable. And we're going to let y equal the total cost of the call. Notice that y is the dependent variable because the total cost of the call, y, depends on x, the number of minutes we stay on the phone. So using those guidelines, we'll write an equation for each calling card. For card A, it costs $1 to connect and then 4 cents per minute for every minute after that. So it costs $1 to connect and then 4 cents per minute after that. So to represent 4 cents per minute, we write 0.04x. And that's going to tell us y, the total cost of the card. So again, y, the total cost of the card, equals $1 plus 4 cents for every minute after. Now, for card B, we'll do a similar thing. For card B, it costs 65 cents to connect. So our final cost, y, of the card, is going to cost us 65 cents no matter what, as soon as we placed a call. And then it's going to cost us 6 cents per minute after that. 6 cents per minute. And remember that x is the number of minutes we're on the phone for. So for example, if x equals 1, it costs an additional 6 cents. If x equals 2, it would cost us 12 cents, and so on. If x equals 3, it cost us 18 cents. And that's how we would figure out the total cost of the call in addition to the connection charge. Okay, so we have these two equations that tell us the cost of making a call with card A and card B. Now the question is, for what number of minutes does it cost the same amount to use each card? So we're solving for x because they say for what number of minutes, and x is equal to number of minutes. So somehow we need to solve for x. And we're told that the situation is that it's going to cost the same amount to use each card. So they're saying the cost of the call, y, is going to be equivalent. Meaning this y and this y are equal to each other. Does it matter what the actual number is? Well, no. It just matters that they're equal. So what we can do is take these two equations and set them equal to one another. So I'll write for card A, 1 plus 0.04x is equal to 0.65 plus 0.06x. Now again, I'm allowed to do this because these y's are equal. So if this equals this and this equals this, then this equals this, right? You can see the kind of the train going on here. All four of these statements are equivalent to each other. So I could set up equations with each of them. Since I'm trying to solve for x, this is the equation I need. So I set my terms equal to each other. Remember, I'm trying to solve for x, so I use equations that involve x so I can solve for it. Okay, so now I've done my substitution. I've set up my equation. Now I'm going to do some simplification. So I'm going to gather like terms. So I'll start off by subtracting 4x from both sides of the equation. That gets me to 1 is equal to 0.65 plus 0.02x. Now I'll subtract 65 from both sides, 65 cents from both sides. And that gives me, let's see, that would be 35 cents is equal to 0.02x. Now I divide by 0.02 on both sides. And finally, I find that x is equal to 17 and a half. So this is saying that at 17 and a half minutes, the calls cost the exact same whether I'm using card A or card B. So for this amount of time and only this amount of time, it wouldn't matter which card you used. Okay, let's do one more example like this. So a 12-inch pizza at Neighborhood Pizza costs $9.95, and each additional topping is $1. The same size pizza at Downtown Pizza costs $6.95, and each additional topping is $1.50. At how many toppings do the pizza cost the same? All right, so once again, we've got these variables here. One variable, we'll call x, is the number of toppings. This is our our independent variable. We've also got y, which is the total cost of the pizza. That's our dependent variable. Y, the cost, depends on the number of toppings we use. Now we need to set up equations to represent each one of the sales schemes. So let's start with Neighborhood Pizza. Their pizza costs $9.95, so y, the total cost of this pizza, costs us $9.95 plus, for each additional topping, $1. So plus $1 for every topping. We also have this other pizza place where y, the total cost of their pizza, is equal to $6.95 plus $1.50 for every topping after. So again, we multiply by x the number of toppings to find out the total cost of toppings for that pizza. Now, we're being asked to solve at how many toppings do the pizzas cost the same. So we're solving for toppings. That means we're going to try to set up an equation that only has toppings, that only has x as a variable. Now they're telling us the pizzas cost the same, meaning that this y and this y are equivalent. So if these two y's are equivalent, that means I can substitute and set up an equation where these two phrases are equal to one another. So I get $9.95 plus 1x equals $6.95 plus 150x. Okay? Again, all four of these expressions that I have circled in yellow are equivalent. So I can set up an equation with either of these on the left-hand side and whatever else on the right-hand side. I've chosen this combination because it gives me an equation where there are only x's, and x is what I'm trying to solve for. Okay, let's simplify. So to do that, we'll subtract 1x from both sides of the equation and $6.95 from both sides of the equation. So on the left-hand side, that means we end up with $3. 95 minus $6.95 is 3. 1x minus 1x is nothing, so I get $3 equals, my $6.95s cancel out, 150 minus 1 is 0.5x. So $3 equals 0.5x. Finally, I divide both sides by 0.5, and I find that x equals 6. So it would take 6 toppings for these pizzas to cost me the same amount of money.